Hit this button. Where's my button? How about that right there? There we go. All right. Let's see here. Oh, yeah. Oh, I guess I brought that down real quick. What's up, everybody? Woo, we're back. Oh, man, we're so back. We're so back we don't even know what we're doing with ourselves. Welcome. Welcome to Everyone Loves Math Live. Look at me. Everyone Loves Math Live. We're back. Hey, I'm Joey. I'm told I got rated. Don Factorial, what's up, man? Welcome to the show. Yeah, let's do it. Let's get into it. Look at this. Look, I moved my office around. I tried to style it. I tried to fit my my aspiring YouTube persona by buying every LED light in existence. And yeah. Oh, Don does math with a new name. Like it. I like it. It's an excited Don. Don exclamation point. I get it. Yes, yes, yes. So yeah, let's catch up. Don, let me know what's going on with you. I'll give you my little thing. So, my name's Joey. I've been around for a while. I've been a math teacher. I've been a assistant principal. I have trained teachers for math. I've been around, man, and now we're trying this. We're trying this because we want to see what happens. So yeah, let's talk about what this is. So let's see. This is my studio, also known as we no longer have a guest bedroom. Like I said, I've YouTubed it up. So look at that. Look at this, huh? Look at that bar. Look at that. You don't get that bar not being on YouTube. So I got the LED bar. I got two different LEDs under the TV there, huh? Right, YouTube. I got the hefty. You can't have a YouTube channel without that hefty thing in the background. That's for camera equipment. And 62 Rishu Fender Jazzmaster, the best guitar ever. Love me a little Jazzmaster. Yeah, maximum LEDs is what it's about. That's what it's about. You have to be. Listen. Here's the problem. here's the problem with the studio. I've got more LEDs over here, and because I moved my office around, you can't even see all the LEDs that I can see right now looking around this office. But we're trying. We're trying to make things happen. I even got a little looping background. Look at this. I got a little, wait, it's this way. Little looping background. And it's just to have something weird going on there, right? We got to get there. We got to get there. All right, Don. So starting on a master's in applied math in a month and a half. Oh man. I get, you know, I wonder how out of the game I could be and still be able to hang. I bet you I am far out of the game to hang with a master's in applied math. But that's awesome. That's really cool, man. Yeah. So yeah. Hey. Oh, let's talk about what I do. So this is a live show. I'm on Twitch and YouTube, although I don't think officially I'm supposed to say that. At least on one of those, but I am. Let's see, what do I have? I've got toys. All right, so I've got a smart board, which right now is holding my website. So don't worry, we'll talk about my website. I got my favorite legal website besides my own, Desmos.com. And so if we ever need to graph something, we got Desmos, the best. I've been touching buttons. Let me tell you, I've been making buttons. Look, I can push this button right here. How about that? Whiteboard and Desmos. Look at that. I'm telling you, there have been some upgrades around. I've got a button for you TI-84 people. Look at that. And then I've got a button for you TI-84 people. And if you want to see my whiteboard. All right. There's all kinds of things that are breaking at every moment as I continue to push buttons and try to get things to work. But that's what we got. Now, the other stuff we got, let me see if I have this up here. Okay, so I'm going to have to do this, right? I'm going to go up here. So in order to get this next piece to work, the thing that I got to show you is I also have, this is for video games. We'll probably do some video games later. All right, Elgato's waiting for us. All right, I'm going to just go ahead and let the Elgato wait for us on that, all right? So let's go. Let's do it. Okay, so all of that is to say I'm working on pushing every button on the planet to make this stuff work. So boom, right there, yeah. All right, how about it? How about those buttons? All right, so hey, let's talk about my website because I've got scrolling text on the bottom. All right, so here's the weird thing. I was trying to figure out the speed at which it should scroll, and I thought I had it, but then I think it was like subliminally making me dizzy, and so I slowed it way down. But if this is like frustratingly slow, let me know. All right, and we'll adjust it. We got you. Okay, so anywho, where was I? Hey, my website. Check it out. This is everyonelovesmath.com. Everyonelovesmath.com. And if you happen to go to everybodylovesmath.com, guess what? Bought it. I bought it too. Guess who's got $9.95 a year? This guy right here. Okay. So if you go to everyonelovesmath.com, you're going to see a couple of things right away. First of all, I right now offer tutoring. I offer tutoring 6 days a week right now because I'm there for the people, man. So I've got tutoring by the hour. I've got tutoring in bundles. And yeah, let me just show you those real quick. All right, so if we go up top, click on tutoring. Let me take you to my tutoring page here. Let's see, come on. There we go. So there's my tutoring page. You can book a 1 hour session or a half-hour session, or you can look at my bundles. I am $50 an hour, but the bundles, you save some money. So let's click on that, right? Do. All right, here we are in bundle land. All right, I'm not gonna give you the hard sell the entire time, I promise. But if you're in a bundle, check this out. You can get a 5, 10, or 20 session bundle. And if you get a 5, 10, or 20 session bundle, you're gonna get either 5%, 10%, or 20% off of that $50 an hour rate. So I try to make it so that if you help me out, with a little bit of stability. You know, you let me pay my mortgage. I appreciate it. You know, I'm cut you a little. Speaking of cutting you a little, in the world's slowest scroll at the bottom, I've got a coupon code right now. If in celebration of my return of the math, this week being the first week back for a lot of schools, if you use coupon code return of the math at checkout, then you will get an extra 10%. 10%? Yes, an extra 10% discount on top of all of this. So, I mean, right now you're losing money not signing up for a bundle. That's how you should think about it. Now, if you're saying, Joey, I don't want to sign up for a bundle, but I want to support the show. I want shows to happen. Yo, I got a button for that. All right, so you could become a supporter. I would love to build up some support so that I can continue to create my YouTube videos and carve out time for me to go live and offer free help. The supporter plans allow me to do that. And so if we've got some supporters out there, again, that allows me the time to be able to make some extra stuff, right? To make some extra resources, devote some extra time to this. So that's where we're at. That's my website. All right, once again, everyonelovesmath.com. And if you're looking to right click on a picture and fall in love, I'm just going to point this out. On my about page, there we go. That's the last official school picture that I took. So it's a right click copy paste away from being yours forever. All right, so just know that. All right, that offer stands. Okay, so all right, so what do we do here? Let's talk about what we do. So what we do here is I've got this show. I've got a couple of hours tonight. Basically, my idea is that I want you to know about the extra discount, that the extra incentive, the extra 10% for using my code Return of the Math. Let's see. I want to do some math, so we'll talk about that in just a moment. And let's see. Yeah, and then we'll hang out. We might even play some video games. We'll see. All right, so let's see. All right, well, so how do you ask a question? So you can ask a question in chat. So I've got, let's see, I'm still working on bringing back my Chatty McChats so that you can see it, but I do have a unified chat on my dashboard that I see. So if you've got internet, if you've got a question about math, 6th grade through like calculus, all right, don't try to ask me some riddle, man. All right, if you're a leprechaun trying to protect your gold, you can just go off with that, all right? I don't need that. I don't need that stress in my life. I'm here to help people. All right, because I felt like I've had some of you before. All right, so yeah, that's it. Let's see. It is hey, what's up, Jillian? Nice name. Nice name. It's almost I think I know how you made that. Welcome. So hey, what I figured we would do. I'm playing with some stuff. All right, know this, that I'm playing with things. So one of the things that I'm playing with is this idea of finding like some functions out in the real world. This is what math teachers think about. So I'm thinking functions in the real world, and like let's feature them here, and then let's do way too much math about it. All right, so I'm about to talk about today's, look at where, push this button, today's featured function. All right, so I've been brainstorming functions. I've got evil plans with functions. I made this dude. Look where, I gotta point this way. I made this dude. I'm thinking about calling him Funky because he's a function, but you know, I might have to, I don't know if Funky's gonna cut it. We might have to get a little more creative with him. So yeah, I was thinking about functions. I'm gonna take you on a little trip, a little function trip that I did yesterday. All right, so when we talk about functions, and by the way, I'm also doing this in the spirit, it's the first week of school, we got to kick off these cobwebs. So when we learn about functions, what do we learn? We learn we got to name them. I'm going to show you how to think about functions as a flow chart. We're going to talk about function notation, domain and range, x-intercepts, y-intercepts, table of values, graph. We can talk about unique features. We've got so much stuff that we can talk about. Let's get to it. Let's do it. So the function that I want, that I was thinking about today is Robux. So this is the currency on the video game Roblox. So if you don't have kids, this is from the video game Roblox. And when you play Roblox, you want your parents to buy you Robux. This is my understanding. And so I went, and I will tell you, I think, Roblox has been around forever. I think it used to be for babies, but now it's like every video game. I think you can do your taxes in Roblox. I think you can run for political office in Roblox. There's all kinds of stuff. I don't understand it. But I was looking at their gibberish website because everything's just gibberish on there because it's basically gambling. It's basically for crazy people to spend money to buy. What do you buy? Help me out. What do you buy on Roblox? But hey, they put this right on their website. This is how you convert from how much money you pay to how many Robux you would get on mobile and console, and then how many Robux you would get on computer, web, and gift cards. And so what I figured we would do is I figured we would talk about how the function that converts these prices to these points, number of bucks. So I should mention a couple things. The reason why they want you to buy Robux from the website is because if you buy it on your phone, then Apple and Google get a little cut. If you buy it on your console, then Sony or Microsoft get a little cut. But if you buy it straight from them, then they don't have to pay out anybody, so they can give you extra fake money. Just figured that was kind of neat. Okay, so what we're going to do is we're going to do way too much work with Robux. I figured, hey, let's do functions. Because what do the teenagers out there want? They want their functions. So one thing that we can do is we can develop a table of values. And I noticed that the table that the Robux has is backwards because the first thing they want you to see is that money. They want you to see the $200 one and hey, that one's the best value. But let's order these in a way that we're used to seeing on a table. So the lowest number is $4.99. I'm actually going to make that my second row. So $4.99 can be thought of as the input for this function. $4.99 is the dollars that are being input, and the output is going to be 500 points. All right, so $4.99 in, 500 points out. What do we got? We got $9.99 in and 1,000 points out. That's the second line here, right? Boop, boop. Let's see, our third line, $19.99, and that gives us 2,000 points. And then $49.99, that gives us 5,250 points. Let's see, $99.99 gives us 11,000 points. And $199.99 gives us 24,000 points. So the reason why we might want to investigate this is maybe we're interested in how the Roblox people figured out how much to charge for this, right? That could be a reason. Another thing is we might want to know for ourselves, which of this is a good value? Are there any parts of this that are better values than others? We might want to figure it out. And if you're the Robux people, you might ask yourself, all right, what if they come out with a $299.99 price? How many Robux should you get for that? Right? Those are questions we should ask. So I looked at this function a little bit earlier, and you're probably looking at it now and noticing something. And the thing that you should notice, I'm going to highlight this, is that the first 3 entries on this list all do kind of go together. So $4.99 going to 500, $9.99 going to 1,000, and $19.99 going to 2,000. So I can see kind of a connection there. And then these numbers are I would just say these are more loosely associated. I don't see the same kind of pattern going on here. And so what we're going to do is we're going to focus in on those 3 points, those 3 pairs of inputs and outputs, in order to kind of figure out, let's dig in and see what's going on. Now, there's one more thing that we should do, And you'll probably notice I did leave the top row of this table open, and that's because there's one other value that I want to include. And so the value that I want to include is 0, 0. That if you spend $0, you get 0 Robux. That is definitely a valid combination, and so I think that should make sense to be included, right? Why not? Okay, so like I said, we're going to focus in on, and let me highlight these. Now that we have that 0, 0, I want to focus in on these first 4 data points. Because after that, they get a little, they get a little funkier. So depending on time, we'll talk about that later. All right, so let's digest this thing and let's figure out what this function does. So this function turns, let's see, what's it do? It takes a 0 and turns it into 0. That doesn't help. Look at $4.99 turning into 500 points. Do you notice that $4.99, we even read it out loud as $4.99. That's a penny away from being $5. And then 5 times 100 would give us 500. Ooh, wait a minute. $9.99. Isn't that a penny away from $10? And 10 times 100 is 1,000. $19.99. That's a penny away from $20. And 20 times 100 is 2,000. So what I'm going to do is I'd like to show you the flow chart for this problem. And I actually have, this is my trademarked in the future flow chart. I call this my function flow chart. We're gonna take an input and we're gonna turn it into an output. And because I've thought about this a little bit earlier, I know that this is, or at least for these first 4 points, we can think about this as a 2-step flow chart. Because there's 2 things that we do to these inputs that lead to these outputs. And let's talk about them. So what did I say we did to these inputs? Well, the first thing we did, I'm going to do it in red, is we added 1 penny. So remember, we added $4.99. We made that $5, and then multiplied by 100. So I'm going to say times 100, and that gave us the output. So that's kind of our flow chart that would take the input and convert it into an output. So, and let's check. So for like 0, let's try the first one. 0 plus a penny. Ooh, wait a minute. 0.01, that'd be 1 penny. 1 penny times 100 is $1. Yikes. So according to this, 0, 0 doesn't fit with this pattern, does it? I'm going to take it off for now. Let's just look at these. So let's put this one in, $4.99. So if I put $4.99 in as the input and add a penny, then we are at $5. So we'll just call it 5 because we're up in our math land. And then 5 times 100, that gives us that 500. Right? So there's an example of the input. Then we do these calculations and get the output. It's just that 0, 0 didn't work in that formula. We just know that it works in real life, that if you spend no money, you get no Robux. All right, so let's get a little bit more specific here. So the input was dollars. That's what our input is. So we need to remember that here the input is dollars and the output is Robux. So in this case, we just showed that $4.99 leads to 500 Robux. All right, so if we're going to talk about domain, domain is just the collection of the x's. And in this problem, in this circumstance, there's only 3 x's. So the domain in this problem, we're just going to list them. It's $4.99, $9.99, and $19.99. And we could put these in a little set notation if we want to look official. There's other things we could do to dress that up, but we just want to list the possible inputs. For our range, we want to list the possible outputs. And I guess since I used a squiggle for domain, I'll use a squiggle for range. So what are we going to put in? 500, 1,000, and 2,000. So those are our outputs. All right, so we got that and that. Got them. Inputs, outputs. We got a flow chart. The next thing I want to do, I'm just going to zoom out a click. I want to take this flow chart And, in the next screen, actually, we're going to take this flowchart and we're going to turn it into a formula. For right now, let's just name this function. So this is the function that it converts money to Robux. We can think about this as like a little Robux ATM, right? Money goes in, Robux comes out, and our function calculates what we would need to make that happen. Okay, so here's where we talk about the function notation. So normally we call the inputs x and we call the outputs y. If we use the function notation, we could also refer to the output as f of x. These are all things that you learn in the Algebra 1. So hey, if you're in Algebra 1, welcome. Welcome to the party, pal. Okay, now we established this flowchart in the on the page before that this is the function that takes the money, adds a penny, right, multiplies by 100, and then it outputs the Robux. Well, we can create the function notation for this pretty easy. What's it do? So we start with the money. We start with x. We add 1 penny. So we're going to add a penny to it. And then we're going to take this whole thing and multiply by 100. And so we can write the function notation, and if we want to clean this up, could we put that 100 in the front? Sure, if that looks prettier to you, do that. But what we just did was we just went from a table to a flowchart to function notation, right? To break down this thing and really understand what's going on. All right, so that's what we do in the algebra when we understand the functions, man. That's what it's all about. Hey, let's keep doing it. I'm having fun. We can also look at graphs, right? So this problem, not the most exciting to graph because we can graph like 4 dots, I guess. But the x and y get a little crazy, right? Because our x's, we need to go up to 20. Our y's, we need to go up to 200. And we don't need any negatives. So if we were going to graph this, let's see. I might put I'll make my y-axis over here and my x-axis over here, right? And if my x's need to just go up to 20, then I might do something like, 5, 10, 15, and then my very last one here will be 20. And then my y values need to go up to 200. So I think I can do 50. Wait, they need to go, wait a minute. Not 200, they need to go up to 2,000. So I think, let's see, I want maybe this to be 500. Get my black ink. We'll do 500, and then 1,000, and then 1,500, and then 2,000. There we go. All right, so with this one, hey, we're doing the best job that we can to get this thing graphed. So let's see. I'll leave it to you if you want to put 0, 0 on there. It wasn't part of that original function. I'll put it on there just for kicks. So what are we going to do? 499, 500. Well, that's a little tough to graph 499. So I'm just going to go like the smidgest to the left of 5, right? 9.99, so just a smidge left of $10 gets us 1,000 points. And then $19.99 gets us just a little less than 2,000 points. So if you look at this, you can tell, actually, except for 0, 0, remember we said 0, 0 was its own thing, those 3 dots are in a straight line. And we also know that they're in a straight line because the formula is linear, right? We're adding a penny and multiplying by 100. And so we're not doing any squaring or anything crazy like that. All right, so look at us so far. Let's look at us. Let's review, right? We took the Robux, the conversion from price to Robux. We centered in on the first couple data points where there was a linear pattern, where things were moving up at a constant rate. We were able to diagram the function into a flowchart so we understand how inputs are turning into outputs. And because of that, we identified the domain and range. In this problem, the domain is just 3 numbers, and the range is just 3 numbers. And the reason why that's the case is because this function only applies for these 3 numbers. If you have $2.99, no Robux for you. There's no conversion, right? If you have $7.42, well, there's no conversion for you, right? You could buy the lower amount and have money left over, I guess. But really, what we're interested in here is just that conversion from money to Robux. Okay, what else did we do? We came up with the formula. All right, again, these are things that you do in Algebra 1 to make sense of this business. All right, as far as y-intercept and x-intercept, you know, if we don't consider 0, 0, then we actually would say these don't have x-intercepts and y-intercepts. Because, let me just go back, it's just those 3 points. And so this function never touches the y-axis, no y-intercepts, never touches the x-axis. If we wanted to, we could talk about, let me just go, where are we at here? We could go back to this formula and we could extend this formula. We could say, okay, we could decide to make this formula work for all the numbers. We could decide to say, all right, if you buy between, if you spend between $4.99 and $9.99, then you'll get proportionally that amount of Robux. And if we do that, if we extend the domain, then we could connect these dots and turn this into a line. And if we extend the domain, then we might be able to talk about a y-intercept and an x-intercept. But, you know, that's just something that we would choose to do. Okay, so our next step with this function is to overdo it, because we could go in and do some more complicated business. There's stuff to be done, but I'm going to save that for another time. All right, so the overdo it, actually, I could give you the challenge. Let me give you the challenge. So looking at the Robux page, right, we talked about these three, the $4.99, $9.99, $19.99. My challenge is that, and maybe we'll do this on Thursday when we're back here together. On Thursday, maybe we'll look at these three. What is the formula that's giving you all these extra, that gives you all these extra Robux? What is that formula? There is one. You can find it. And maybe we'll do it together on Thursday. How about that? All right. Can I hit that button? There we go. Look at that. I'm still getting used to it. How's everybody doing? What's going down? What's going down, Internet? I'm happy to see you. I'm happy to be seen. Tell me how your lives are. Hit me up. Hit me up. What's going down? Ooh, I love checking on stuff. Okay, boom, 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 boom. Great. Cool. I'm just checking to make sure that my internet is not on fire, because it's been a second since I've done the old live stream, and the multi-stream, that'll take it out of you, man. That'll take it out of you every day. All right. Hey, Jillian's still with us. Ooh, so Jillian, one thing that I got to figure, let me see. Can I put this? Where was this that I had this? I had my camera here. Nope, that's not where I wanted to go. I think I wanted to go, let's get this. If I go to my whiteboard, no. Okay. So one thing that I've got, let me go back to camera focus with graphics. Okay. So one thing that I've got to figure out is I've got to figure out my unified chat, and I want to put it on stuff, but I don't want it to like overtake everything. So here, maybe I'll just play with that. Yeah, that's what I want to hear. But check this out. I can go soc, right? I'm going to add my soc. Look at this. So I can take chat. What if I took chat and moved it here, right? All right. And I can put that right here. Right? Look at that. And then, let's see. I would want to move that underneath some stuff. There we go. Yeah. All right. So, ooh, look at that. And it disappears. Look at that, man. All right. Party. If I type party. Yeah, that's right. Party. I'm just checking to see. So when I type party in my unified chat, it doesn't show up in the YouTube chat. And so I've got, I'm still kicking the tires on that. But, and folks normally ask, I'm using Social Stream. Social Stream is given my unified chat. So we'll see what's up with that. In fact, I'm going to spam this. Hi. There we go. And I'm going to type party one more time. There we go. Yep, to see it kind of just... I'm trying to make everything beautiful, fade up, and all that business. Okay, so it's probably time for us to talk about video games, right? We should probably do some video games. And I want to do a math teacher approved video game. So if you give me just a moment, I will be right back. All right, I'm going to hit this button. And hopefully it doesn't blast you with music. All right, but you might want to turn your music down. All right, here we go. Yep. All right, there we go. All right, I'm going to play it a little bit lower. There we go. All right, internet. I'm getting us ready. For gaming. It's gaming time. I've got a lot going on now. Let's get this muted. All right, here we go. Boom, 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 doo, doo, doo. All right, doo, doo, doodly, doo, doo. Smooth that out. Let's go back over here. All right, there we go. Oh, stand by. One more thing I gotta fix. Yeah, we got one more thing to fix. Let's fix that, shall we? I'm gonna go to that. I'm gonna hit that. Oh yeah. Oh yeah. So, ladies and gentlemen, I'm gonna remind you, if you have a math question, please ask it. I'm ready. I am ready for your math question. And I should still have chat working up here. Again, kicking the tires, man. Kicking the tires to get everything working. So when there's not math, we can do a little pit cross. Jillian, have you played pit cross before? I can't remember if I've told you about it. Let's see. I'm gonna get the music, kicking the music up a little bit. All right, that should be in the background. Let me know if that music is too loud or distracting, or if it's too soft. All right, so pit cross, math teacher approved. All right, get yourself down. Oh, you're in for a treat. Get yourself down with some pit cross. All right, so here's what I'm gonna do. I'm a psycho with pit cross. So you can tell. Look at this. Just so you know, those are hour counts. They've released all these little packs. I've spent 25 hours on this one, 26 hours on this one, 21 hours, and I've played these multiple times. I have a little bit of a pit cross sickness, yeah, let's work on that right now. Okay, so all of these have already been. All right, I'm gonna give you the pit cross tutorial. All right, so when we're working on pit cross, the thing to know is that I've completed all these puzzles, but that doesn't really mean anything for me, because you don't use the picture at all to help solve the puzzle. Instead of using the picture, you just use deductive reasoning. All right, so I know it's a great sell, but it actually is fun. So let's click on this one. Let's play this puzzle. All right. All right. So I'm kind of on purpose heading back to here. because the 5 by 5 grid, that's the easiest grid. All right, so we're going to start with the easiest grid. We're going to work our way up to get more wild, okay? All right, so here's what this means. You see that 1 on the left. What that 1 means is in this row here that I'm scrolling through, one of those squares, let me just show you, one of those squares should be filled in. All right, so notice when I fill in one square, the 1 grays out, okay? So it's telling us one of these squares should be filled in. Okay, so if one of those squares is filled in, then all of the other squares in that row must not be filled in, right? So that 1 could mean this. It could mean that only the second square is filled in. But that's not all it could mean, right? It could mean only the third square is filled in. All right, so 1 just means there's one square that's filled in, and the other squares are blacked out, X'd out, however you want to call it. Okay? All right. So let's see. What you might want to do is you might want to look for some easy ones at first. So like, look at this row. This row has a 5, right? So there's 5 squares, and this says that 5 squares are filled in. So what we now know is, oops, ooh, I'm getting a little imprecise D-pad action. I haven't upgraded my Switch controller yet. Okay, so that 5 there means all 5 should be filled out because there's only 5 squares and 5 are filled in. Okay, speaking of which, this one here, look at this middle column. This middle column has a 1 and then a 3. So that means there's 1 square filled in, and then a blank, and then 3 squares filled in. There's actually only one way to do it, because there's only one way to get those, all of those to fit. By fitting this in, the 1 blank 3, notice that now I've figured out which of these 5 up top here actually gets filled in. So now I'm going to do a little maintenance. I'm going to X out the other ones in that row. Okay, look at this column. See, this column had 1 in that column, and it's already got 1 filled in, so I know I can X out everything in that row. All right, now we're playing pit cross, baby. Okay. Oh, look at this middle row. This middle row has a 1 blacked out, and so we can cross everything out on that row. All right, now we're getting there. Now we're doing math. Okay, from here, oh, look at this. We filled this out. This one's grayed out, so I can hit this. All right, in this bottom row here, there needs to be 3 blocks in a row filled in, and all I have to play with are 3 blocks. So I'm going to fill those in. All right, so now all 3 blocks are filled in. We're good. What else do I got? Oh, right here, 1 and 1. 1 and 1. And boom, we've cleared it. So the thing to keep in mind, so this was a flower. I didn't remember that it was a flower when I clicked on it, and at no point in this game did I care that it was a flower, right? That's not what's important. What's important is that we're using our noggin. All right. Hey, what's happening? Welcome, welcome. All right. So let's do some more pit cross. Let's do it. I think this is supposed to be a frog, but remember, the frog doesn't matter. We're doing math here. All right, so let's see. I'm gonna do this until it gets frustrating for y'all to watch. I will tell you, pit cross is where it's at. All right, so let me put something out there. If you are a high schooler taking geometry this year, really anything higher than geometry, you should be playing pit cross, man. If you want an airtight proof, pit cross. If you can fill out a pit cross, you can fill out a proof. All right, so let's do some easy stuff here. Look at these 5s. Oops. So that should all be filled in. This should all be filled in, right? Because there's 5 blocks, and 5 blocks need to be filled in. Same is true down here, right? 5 blocks, 5 need to be filled in. All right, that took care of a whole lot of business. What do we got? Well, the 2 and the 1, that's already done. This next column, see where it says 3 and 1? That must be a block, because there's the 1, and then 1, 2, 3. There's the 3. All right, this one's already grayed out. So we can fill those up. This is 3 and 1, so that's the same as the row we just did. And then this needs to have 4 in a row. And that's how you do it. Picross, once you start like really locking into the logic, it gets super, super rewarding. Like, it's really fun. Okay, and then you can go crazy. So you'll notice that my record on the frog was 7 seconds. I don't say that to brag. But you can also just go a little insane with these. All right, so let's do. What is this? This is supposed to be a yacht. I can't say that I see it, but let me show you yacht. All right, so what do? We can fill in the fiver. Right, there we go. We got that filled in. This first column is now done, right? It had 1 that needed to be filled in, and 1 is filled in. So we're going to cross all those out. Boom. The 3 down here, we need 3 in a row. Well, there's 1, so these must be the other 2 to make that 3. And look at this. Oh, I can block those out because we need to have 1 separated by 2. So there's the 2 already, and here's the 2 already. Let's see, this needs to be 2, so there's 1. Oops, sorry. 1, 2. And that's the rest of that row. All right, we need 2 blocks here, and they can't be right next to each other, so there needs to be at least a blank in between them. And then that completes our puzzle. Are you picking up on the Picross magic? This is Picross. Picross is the bomb. All right, it is just the bomb. All right, this is a bag. According to Picross, this is a bag. Again, the pictures don't matter. It's all about the math, baby. It's all about the puzzles. Let's do it. All right, so what are we looking at? Let's see. Oh, we got another fiver. You start to really love them 5 out of 5s, right? So 5 out of 5 of the blocks have to be filled in. If we just start with the 5 out of 5s, man, we got very little left to go. In fact, the only thing I need to do is put a block right there, because a block right there would complete that 3 in a row, and then vertically it would give a 1 space 3. So I can do that. I don't have to put those X's in. Those X's are just there to help you. They're not required for the game. All right, so yeah, you can go crazy. So by the second page, now we're looking at 10 by 10s. So let's do an owl. Let's do a 10 by 10. All right, just so I can show you. In addition to 10 by 10s, the Picross puzzles have 15 by 15s and 20 by 15s. And then depending on the level of Picross, there are a couple of different variations. So there's a ton of stuff on here. Okay, so what can we do? What jumps out? So we have 10 across and 10 down. And notice that they've already filled out the 0 columns for us. So they filled out the first column and last column. But what that means is that there are 8 blocks left. And this row right here says 8 blocks in a row need to be filled in. So boom, got them. Sometimes what I like to do is I like to fill those in and then just go block by block. So here's this column here. I mean column by column. So this column needs to be 6. So let's pretend there were 6. 1, 2, 3, 4, 5, 6. This block has to be filled in. There's no way to have 6 in a row and not have that block filled in. That's what I mean by, like, get yourself a geometry level proof. Picross. Okay, but look at what this started. That row starts with 3 in a row. So I know it's got to be 3 in a row and then a block. Then we need 2 in a row and then a block and then 1. We have no choices. It's got to be 2 and then 1. Okay. Once I fill that out, I don't think there's any choices for this one either. If you have a 3 blank 2 blank 1, there's only one way for that to fit. Okay, so let's see. What can we do with all of this? Well, let's go back to this first column. See, there's 3 in a row here, right? Even if, and remember, we need 6 in a row. Even if the 6 started here, we'd be like 1, 2, 3, 4, 5, 6. The more you play this, the more you realize this very top box will never be able to be filled in, because you would need 7 to be able to get up there. All right, so you start to fill that in. What happens here? 1, 2, 3, 4, 5, 6, 7, space 1. All right, so the 7 could fit here. And if we do 7 space 1, that gives us 1 block of wiggle room. There's a strategy you can use there. I don't want to give it away. All right, so let's see. This first row is 5 in a row. 1, 2, 3, 4, 5. So no matter what, the middle 3 are going to be filled in, because you can't make a 5 in a row without filling in the middle 3. All right, well, this one's a 1 in the column. Looking at the columns, this is a 1, and this starts as a 1. So those all have to be blacked out, X'd out. Okay, now I'm going to go and look at the row. And this row is a 2 in a row, separated by a 2 in a row. Well, this has got to be one of those. And then, however we make a 2 in a row here, it's got to involve that middle square. All right. Once we've got that, then we're able to start partying, right? Because look at, now switch to this column. You switch to that column, 1, 2, 3, 4, 5, 6, 7. Those have to be filled in as part of the 7. Right over here, these have to be filled in as part of this 7. All right, now we're partying. Let's see, what are we going to do next? Oh, look at this row. So I'm talking about the row. These are all 1s in a row. So that 1 has to be by itself and that 1. But then these could be there. All right, so there's only one way that all of these are going to fit, right? If you do it right, there's one way to make it work. All right, so what are we going to do? These are all singletons as well. So I'm going to put X's there and there. So the 1 that's remaining in this row is either here, here, or here. So let's look. It can't be here because we need to have 1, 1, 1 in that column. Let's see, it can't be there because we need 1, 1 in that column. So it's got to be this one. All right, so there's a whole lot of deductive reasoning going on here. All right, so I'm just going to fill this one out. And as you get good, you start to, I mean, there are so many, it's just like math, there's so many patterns on top of patterns that you start to investigate for yourself. It's really fun. All right. The music kind of stinks. They've never had good music. And so I would recommend, and by the way, you don't want to listen to some kind of repetitive track for this anyway. This is like where am I not paying attention? This is like the perfect podcast game, if you ask me, right? You just kind of zone out, do your podcast, listen to your podcast, and play a little Picross, okay? If you have a Nintendo 3DS, I just got to put that out there. You got a Nintendo 3DS, you can play the Picross 3D. It's the bomb. All right, so just so you know, math approved. Math approved. All right, let me hit this button. I'm going to hit this button. I'm going to take this down to there. And listen, y'all. This was Everyone Loves Math for the night. All right, we did a little bit of math. We played a little bit of games. I'm going to sign off. I'm going to go have an evening. I'm back here again, 8 o'clock on Thursday. And so if you're looking for some math help, come on by. 8 o'clock on Thursday, Eastern time. Come by and get your math help. Until then, I will check you later.